In this video, we are going to do the type of circular motion problems called car topping a hill. It doesn't necessarily have to be a car. In fact, in this example, we have a motorcycle. So we have a motorcycle is traveling up one side of a hill and down the other side. The crest is a circular arc with a radius of 45 meters. And we want to determine the maximum speed that the cycle can have while moving over the crest without losing contact. So what we don't want to happen is what's happening to this car in this picture. So basically, if the motorcycle goes too fast, it'll go up in the air, meaning it loses contact with the ground. So we'll start by visualizing this. So here we've got our motorcycle cresting the hill. We've got a circle with a radius of 45 meters. Remember, the centripetal force is that center-seeking force, so it'll point towards the center of the circle. In this case, the center of the circle is down, so I labeled the centripetal force going down. Now remember, the centripetal force isn't a force in and of itself. Multiple forces or just one force cause the centripetal force or affect the centripetal force. So we've got the force due to gravity pointing down and the normal force pushing up on the motorcycle. So the centripetal force, that's the net force that's acting on the motorcycle, is going to be Fg minus Fn. And we know that the centripetal force is equal to mv squared over r. So it kind of looks at this point like we have too many unknowns, but let's think about what we actually are looking for. So we want to determine v, so this right here, and we want to determine the maximum speed that the cycle can have without losing contact. Now, if the motorcycle loses contact with the ground, there will no longer be a normal force. So to find the maximum speed, we want to set the normal force equal to 0. And that's because when the cycle loses contact with the road surface, there will no longer be a normal force from the surface. So this Fn just goes away. Fg is equal to mg. So this whole equation boils down to mg equals mv squared over r. So hopefully you'll notice that those m's cancel. Plug in 9.8 for g, v is what we're looking for, and r is equal to 45. Multiply both sides by 45. Take the square root of both sides, and we get that the maximum speed is 21 meters per second. Now, if we look at this, we can again see this is the type of problem where the mass does not matter. So again, let's think about why the mass does not matter. Well, the mass doesn't matter because if there's more mass, then there will be a larger gravitational force acting on that object, which means that the normal force will be greater. So that's why the mass ends up not mattering, because when the mass increases, the other forces increase.